Hello everyone, this is my presentation on the Lewis 25. The Lewis 25 is a center console hybrid bay boat designed not only for the avid fisherman but for family-friendly accommodations as well. This boat is built out of composite materials and is meant to be simple but stand out from the crowd and really hit those performance aspects that the customer was looking for. As you can see here, this boat will be spending a lot of time in South Carolina, both on the inland waterways as well as offshore when the weather allows. Some major constraints put on this boat was that it needed to have a beam of less than 8.5 feet, that way it can be trailered without a permit, and also to have an electric head beneath the console. Additionally, for fishability, we wanted to have a draft of less than 20 inches of water, and as you can see here, there was plenty of data available and options available for boats within this class of the hybrid bay boat. This really allowed us to hone in on some specific parameters that the customer wanted to focus on, and we really could tweak the numbers how we liked. Some inspiration for the exterior, the Stoner Boatworks was really the favorite. It has those classic and clean lines that offer a really nice look. And for the interior and blending both aspects we talked about earlier, the regulators, the Everglades, and Pathfinders all do this very well, and they took up a major portion of that parametric study. You can see this again on the GA views starting at the bow. You have plenty of storage and seating arrangement options, and this is also offered in the stern of these boats as well. And for fishing specifically, we opted to go with open gunnels so that we could have plenty of rod storage without relying on side deck space. Again, this boat is being built out of composite materials, so we have a three-piece construction outside of the hull shell. You have the structural grid, the liner, and the deck cap. And we wanted to have this all splashed off of molds in case we wanted to build more of these in the future, so that was a really big challenge throughout this entire process. For the hull design specifically and hitting numbers that we wanted to set within that parametric study, the first design had a very high displacement and displacement to length ratio. This was solely because it was built out of three separate surfaces, which didn't allow a lot of customization and adjustments within the surfaces, and the hydrostatics did not come out where we wanted them to be. So for the next revision, we were able to get that displacement down and the displacement to length ratio down and within range of those boats on the parametric study. We started with a singular surface here and we were able to adjust those control points and really get those numbers where we wanted them to be. For propulsion, we wanted this again to be simple. The customer has had great results with Yamahas in the past, so we opted to go with a single Yamaha 350 horsepower V6 outboard. After that, we conducted a visibility test in order to start designing the console and how high the windshield needed to be. After the Yamaha outboard was selected, we had to go about a propeller selection. You can see which one we selected in the bottom right image. However, we conducted a large study on this and found that there aren't any effective options out there. You're always going to have a very high tip speed or cavitation issues, which will cause longevity issues in the propeller. After all of that was selected, we conducted a CFD analysis. The goal of this was to hit a top speed of around 45 knots. And with hitting a top speed of 49 knots in the analysis, the required horsepower was 365. That kept us well within range and allows us to hit that top speed goal with the 350 horsepower engine. Again, this boat was built out of composites, so we decided to design this boat structurally to ISO standards. You can see a lot of these calculations here on the left and an example of the laminate schedule on the right for the bottom plating. This was the simplified ISO method, so this might not be the most effective method for designing a structure for this bay boat. However, it is done to ISO standards in a certain method. You can see all of this design here after the calculations in Rhino. You have the structural grid, the liner, and the deck cap, and then in the bottom left you can see that all molded together. This was very difficult to do, again, was trying to keep in mind throughout this entire process that this is needed to be built and splashed off of a mold. In the 2D drawings, you can see all of this exploded again on the left. You have the deck cap and the liner and the structural grid all bonded into the hull. And then again, because this could go into production in the future, we opted to go with a shoebox joint for the hull to deck joint. Weights and stability is very important, especially on a smaller vessel like this. It can vary so easily. And we had an LCB in the hydrostatics of just under 4 meters aft of station 0. And as you can see through the 3 separate weight studies that we did, the LCG in all 3 of those was in a very acceptable range of the LCB. A lot of this was determined by the placement of the systems. First, we calculated a duty cycle in order to predict what house bank system requirements we needed. We opted to go with a solid-state marine battery for this. For fishing specifically, we have a Garmin trolling motor up at the bow and a West Marine Group 31 battery for cranking the Yamaha. You can see a lot of the systems arrangements shown here on the GA view and on the inboard profile view. The batteries and tanks all placed in order to hit those numbers that we needed for the weights and centers. As you can see, we have a 72-gallon fuel tank, a holding tank, and a freshwater tank as well. You can see all of these layouts done in Rhino here. The fuel tanks and water tanks are completely integrated into the hull, and the approximate location of the electric head is shown here as well. In terms of fishing specifically, the customer wanted to go with Gemlux rod holders and cleats. These are stainless steel and very popular across this industry. Some overall takeaways from the design, again, keeping in mind that this boat is going to be built out of composite materials, offered a lot of difficulties and multiple trips through the design spiral in certain areas. I would have loved to spend more time on the hull to deck joint and really nailing that down not only on the drawings but in Rhino as well. And as you can see here, this is the final product. The overall look of the boat is very clean and the customer wanted this to stand out. So we opted to go with a different colorway for this, and I really think it pulls the overall look of the boat together. It's functional and it's unique, and it also hits those parameters we wanted to hit from the beginning. I hope you guys enjoyed this presentation and liked the design of the Lewis 25.